Thanks for coming, everybody. So my name's Sean Brilliant. I'm a marine biologist and I work for the Canadian Wildlife Federation. And I just want to give you a quick talk today. It should take about 20 minutes, and simply we're going to talk about sharks. And I wanted to take a chance to talk about what they are, why they're special, what the relationship here is in Canada, and maybe leave you with a bit of an appreciation for why they require or why they should have our attention on these things. So to start, let's just talk about our country for a minute. Second largest country in the world, 9 million square kilometers in land mass. What we tend to forget, though, is that we also have 6 million square kilometers of ocean. So we have a lot of ocean on this planet. We're responsible for a lot of ocean. Some of us get to enjoy it. I forgot to mention, I'm based in Halifax, so I happen to be on the Atlantic Ocean. I'm based in Dalhousie University, which is where I am right now. Those of you who are on the ocean get to enjoy the privilege of being on the ocean. Those of you who are not on the ocean have to realize that you still own a part of the ocean. Canada has a large section of ocean that is ours and that we are responsible for looking after and that we can take advantage of as well. And you have a say in how we manage and deal with our oceans. We also have a lot of creatures, lots of wildlife that live in these oceans, lots of fascinating creatures, many of which we don't know a lot about. Today we're going to talk about sharks in particular. Many of you, I expect all of you, know what sharks are. You've certainly heard of them. These are generally fast swimming fish. They are predators, often of fish, sometimes of large mammals, sometimes of invertebrates, but this is what they are known for. When we talk with people and ask them about sharks, there's not a whole lot of knowledge or understanding about what makes sharks special or why they're different, but people have this inherent feeling that they are different. And I wanted to talk today about what some of these features are and why they're important. So let's get started and talk about these things. The first thing that's amazing about sharks is how their bodies work. Their bodies are very different from many other animals in the world, and certainly different from many fish. Here's a cut through of a typical bony fish, a typical fish that you'd find in the ocean. And this little thing that you see right here highlighted in yellow is what's called an air bladder. Many fish have air bladders in them, not all, but many fish have air bladders, and this is what controls buoyancy as they're in the water. It lets them float, but control where in the water column that they float. And it's a very important development, evolutionary development that they have, a tool that they have for living in the ocean. Sharks don't have an air bladder. If we look at this cutaway of a shark, what sharks do to control their buoyancy is they use their liver. They have a very large liver located here in yellow, and it's filled with oil. It stores energy for them, which is really important, but it also affects their buoyancy. It's not as good as an air bladder. In fact, most sharks are what we call negatively buoyant, so they tend to sink if they don't continuously swim. And so some sharks do continuously swim, but it does help control buoyancy as well as be an important part of their energy storage system. So this is the first thing that stands out. They float with oil, not with air, even though they're a fish. So they're very different this way. Another thing is fish that live in the ocean are constantly ingesting salt. Salt is a difficult thing to live with for most organisms, and fish get rid of that salt through their gills or they pee it out. I don't know if I'm allowed to say pee in a webinar, but anyway, they get rid of salt in all these different ways. When you eat fish meat is not salty, and it's because fish get rid of the salt. They don't let salt come into their bodies. Sharks are different. Salt doesn't enter their muscles. Sharks have a chemical that they keep in their muscles called urea that we actually pee and get rid of, but they use urea to keep their tissues at the same level as the salt around them so that salt doesn't even enter their tissues. This is called being isoosmotic, is the technical term. So they're the same concentration as the water around them, so they don't have to deal as much with absorbing and eliminating salt from their body. They already have some different chemistry going on that protects them from the salt around them, and this makes a big difference. Second here. Great. This is another thing that's often very well known about sharks. This top skeleton that we're looking at here is a typical bony fish. The bottom skeleton is a shark. Many of you have heard about this before, I'm sure, but sharks don't have bones. These look like bones, but they're not bone. They're made of cartilage. So sharks have skeletons that are composed entirely of cartilage. Fish have bones, actual bones with them as well. Cartilage is the stuff that our earlobes are made from. So, of course, they feel quite different, but if you're grabbing onto your ear, this is about how stiff Sharks can be a bit thicker, but this is about how stiff shark bones can be. They're made of cartilage, so they're very flexible, very strong still. We have lots of cartilage in our body. It's what keeps our bones together, but they have no real bones, which is absolutely amazing. So they have cartilage and not bones, as opposed to most fish. Also, you'll notice from looking at the skeleton, sharks don't have ribs. They don't need them. They have the muscles that hold things in place, and they have cartilage and connective tissue that are keeping everything together. So it's amazing that way. The other thing neat about cartilage is that cartilage can continue to grow through life, and it can also shrink. So as sharks live, they can change size. Sharks can get a little bit bigger, of course, because most things grow. They can also ungrow, as I heard someone say one time. They can get smaller and shrink when times aren't as good and they don't have as much food. So they can control their skeletal structures sort of a bit differently from everything else. Crazy system. These animals are quite unlike many other animals on this planet. The jaws and the teeth are something that are very well known for sharks, and here are some jaws. I think this is of a sand tiger shark, and if we look closely, for example, at the bottom jaw, these large spiky teeth that are designed for grabbing onto slippery fish and not letting them get away. Most people know, of course, that shark teeth continually grow throughout their life, and they grow on this conveyor belt in their jaws, continually moving the teeth forward. As teeth are used up and fall out, then the new teeth move up in place. And what happens is sharks will often have multiple layers of teeth in their jaws, constantly revolving forward over some time, and making sure that sharks always have sharp teeth that are useful and can be used to get their prey. It often seems quite intimidating and frightening, but it's simply a mechanism that they have in place to make sure that they're always able to capture the food that's necessary for them. So they have teeth that are constantly growing, forever growing teeth. They've always got sharp teeth, always new teeth up and ready to go. Another thing that's amazing is the skin of sharks. These are micrographs. These are close-ups of the skin of sharks using a very, very powerful microscope. Okay? And if you look at these for a moment, hopefully you'll realize they look a little bit familiar. They look like teeth. And it's because they are sort of a type of teeth. And this is what shark skin is made of. Very, very small, but essentially small teeth-like projections all over their body. We've actually started to copy this. I don't know if you've seen these in Olympic swimmers. Olympic swimmers will use shark skin suits, to try and swim a little bit more quickly. And it turns out the skin of sharks actually helps them move through the water more efficiently, and this is part of the reason why we started copying it. I don't even know if those suits are still legal in the Olympics or not, but they certainly helped people swim more efficiently, at least when you're swimming that fast. And they will definitely help sharks in the environment that they're in as well, because of these teeth-like projections all over their skin. And if you touch a shark's skin, it feels kind of rough and sandpaper-like, and if you go in the other direction, it's very rough, and it's because you're going against these teeth. So they have teeth-like skin all over the body, in addition to these amazing adaptations in their jaws that continually produce new teeth. Amazing things. Let's go on. Their eyes. How's this for a beautiful eye? Isn't that beautiful? Sharks have amazing eyes. They have eyes very similar to ours. They are strongly tuned to seeing in the dark. They can see in dim conditions really well. They can't see color very well, although some sharks seem to be able to see some shades of blue and green, but their eyes are very well adapted to the dark in the ocean, and they can focus on things really well. They have excellent eyesight. They also have excellent ability to smell. Many sharks have sort of openings on the front of their face that sort of look like nostrils. They're not exactly nostrils because they don't breathe through them. They call them nares generally. But they will bring water in through these nares, and they can detect smells and scents and tastes in the water. A large part of the shark's brain is devoted to understanding smells and tracking things in the water. And so they have an incredible sense of smell as well. They also have ears. And there's no ears on this shark, but I had to put this here to remind myself. And you can see all these beautiful eyes. They have beautiful eyes. Sharks have ears similar to ours. They don't have an earlobe, so you can't see anything. But they do have an ear that's connected to the outside world, to the water around them. And they can respond to sound. Sound is essentially pressure. But they have an excellent sense of hearing in this sense as well. So they can hear things in the water. They're attuned to these types of things. As well, like many fish, and many fish have this, sharks have what's called a lateral line system. So down the sides of their body and up to their head and often around their eye and so on, there'll be this system of pores and openings. And this lets them sense pressure and water movement around them. Many fish use this skill so that they can school with other fish beside them and make sure that they stay close, and they can detect when predators are coming. And sharks have this system as well that lets them know what the pressure is like around them and how the water is moving around them as well. So they're very tuned to how the water is moving. And finally, most amazingly, sharks have these little tiny bumps all over their face. If you look close on this blue shark, you can see little tiny bumps. And on this previous picture, these little bumps here on the nose. And on this previous picture, you can see what looks like freckles all over the rostrum, the nose of this shark here. These are a special organ designed to measure electricity. Sharks can measure electricity. That's amazing. Why do they measure electricity? Well, it turns out whenever we flex a muscle or move our body, whenever a fish swims, you send an electrical impulse to the muscle to tell the muscle to flex. Sharks can detect that. There are other fish that have this ability too, but very few fish have the sensitivity that sharks have. So they can actually detect when those muscles are flexing and where they are. They can find animals that are hiding in the sand. There's even some evidence that they can use these organs to detect the magnetic field of the Earth, so they know where they are on the Earth. And they can also detect temperature with them as well in a very fine scale. So they could be something that helps with navigation. So this is an amazing ability. So sharks, another amazing ability, why their bodies are so different from everything else, they have these super senses. Many of their senses are very, very high tuned. Sort of unsurprising when you consider their role in life as a predator, where they're designed usually to chase and catch prey. You need to be very good at detecting your prey and knowing where they are, and sharks have certainly reached that ability. Sharks' bodies work differently as well in how they reproduce. Many sharks can give birth to live babies, just like mammals. Some of them even have a placenta like a mammal, and this is a fish. Not all sharks do, and not all have a placenta. Many do, however, have live babies. Those that don't have live babies will produce eggs, and the egg cases of sharks are very unusual looking, very thick and rubbery, very strong. The baby that's inside, and you can see one of the egg cases here, the baby that's inside has a very large yolk sac attached to it, so it has lots of energy. Some of them are very strange shapes and very tough. But the thing that's most important and critical about shark reproduction and birth is whether the shark is giving birth to a live baby or whether the baby is coming out of an egg. In almost all cases, sharks tend to produce relatively few offspring, but the babies are very well equipped to survival. They swim fast, they can avoid predators, and they can go after prey very shortly after coming out of the egg or after giving birth. And that's part of the reason why they're so successful. The problem here, or not the problem, the challenge is that they are very slow to reproduce. It takes about 9 months for humans to make a baby, and that's the gestation period. For sharks, it can often take up to 9 months for sure, and some even longer, up to 12 months to develop a baby shark. So they're very slow at reproducing, and they have relatively few babies when they do produce them. So yet another big difference for sharks. Some of them lay eggs, and some of them give live birth. And some of them give live birth very much like mammals by feeding them, developing them in a placenta like we do. Amazingly different creatures. This doesn't look like a shark, but nothing to do with sharks. This is Tyrannosaurus rex, an artist's conception of what Tyrannosaurus rex looked like. The reason I put this on here is because sharks existed before dinosaurs did on this planet. Sharks began to appear in our fossil record about 400 million years ago, somewhere around the age of fish, when many fish started to show up. Of course, that's when sharks showed up. Modern sharks started to appear in the Cretaceous period, which is the time when dinosaurs were around. And most of the sharks that we have around us today have not changed since that age of dinosaurs and reptiles. They swam in the ocean with giant reptiles and with dinosaurs wandering on the land in particular. The form and function of sharks have not changed very much since then. They developed before the dinosaurs, and they exist now in very little difference. During that time, there have been a number of changes that went on the Earth where large amounts of animals have gone, including the dinosaurs. And despite these extinctions, these massive changes to the Earth that caused animals to go extinct, sharks have survived because they're so perfectly attuned to the life and the world that they're living in. So, another amazing thing about them. One of the few, and there are many animals who do this. There are several animals that have not changed, that have evolved before dinosaurs and survived since then. Crocodiles are another example and turtles. But this is another thing that makes them quite amazing. Just as an aside, I want to mention very quickly, There is a shark called Megalodon, and it seems to be gaining some popularity. This is a picture of a scientist who's standing in the jaws of Megalodon and holding the jaws of a modern-day great white shark. This was a giant shark with giant teeth, of enormous size we can only imagine. At one time we thought it was related to the white shark, but now we're starting to think it's more related to salmon sharks and other fish-eating sharks. Nonetheless, it was a giant, absolute giant. However, there's a lot of myths around this thing, and I want to dispel two of them very quickly. Number one, Megalodon did not exist with the dinosaurs. There's a lot of stories out there about giant 50-foot shark that used to eat dinosaurs. Megalodon only evolved 20 million years ago and went extinct like 2 million years ago. It did not exist with dinosaurs. Number two, Megalodon does not exist today. Anyone who tells you that they do are telling you a story, and they're trying to entertain you. It is not true. There's people who say, well, some people think maybe one exists in the ocean somewhere and maybe it's out there. This is just fiction. And don't let them confuse you. If someone is telling you that, then they're simply a storyteller and you don't believe them. So, just wanted to touch on Megalodon. It certainly did exist. Look at the size of this tooth, just mind-boggling. But there's a number of myths around them, and I want you to keep that in mind. Okay, so sharks are so different from so many other animals. It's crazy. Their bodies are built differently and they act differently. They float with oil, not air. They balance the salt water around them. They have no bones. Their teeth and skin are different. I didn't even talk about, for example, many of them can generate their own heat, just like mammals, and many other large fish can too, so they can keep themselves warm. They swim very fast. Their muscles act differently and they're designed differently. These are amazing creatures. They reproduce differently from many other animals as well. Some of them give live births, even though they're a type of fish. They develop leathery egg cases. They spend a lot of time investing in their babies so that they're ready to survive and become survivors when they come out, but it makes them very slow. And they sense the world differently. Sight, sound, smell, pressure, water temperature, and electricity. And this makes them very good for being constantly aware of what's going on around them. And finally, these creatures, these almost perfect creatures for the world they're living in, developed these skills before the dinosaurs existed, and they have the same ones now. I also didn't even mention how they're so different because of how they behave. We recently spoke with William Winram, and we've done a webinar with William, and William is a breath hold diver who uses his skills to help scientists tag sharks, and he spent a lot of time swimming around and interacting with sharks, and his insight for how sharks behave is also amazing, and we didn't even talk about that here. Sharks will change their posture as they communicate with each other. They'll roll their bellies. They have a whole system of communication. They're not just simply mindless machines that are out there. They interact with each other and with their environment, and it's amazing to get a better understanding of what these things are. Okay, so this is why sharks should blow your mind, and this is why they are kind of amazing. Let's talk about Canadian sharks now. So there are sharks in Canada, whether you know it or not, and they are our sharks. We have about 30 species in total that have ever been found in Canadian waters. Some are common and some are just sort of surprise animals that have showed up in an area and may have come here by mistake and got lost. But in general, we can say that there are about 12 common kinds of sharks that come around, but we have seen about 30 different types of species. Let's take a look at some of these now and see what they are. A common one, first of all, is a dogfish. This is a little dogfish found on both the Atlantic and the Pacific coasts. It is something that many of us have come across or you may have heard about. They've got a little spike on their fin to help protect themselves. They're not a very big fish, maybe a meter or a little bit more in size. Blue sharks are another very common species found in the Atlantic and the Pacific. These can get quite large. They live in the surface part of the ocean, particularly out deep, big predatory fish eaters. Porbeagle sharks on the east coast and salmon sharks on the west coast are generally the same genus. This is a large fish-eating shark as well that occurs in the pelagic or the open ocean system. And finally, on the east coast, we call them Greenland sharks. There's another species that's very similar called a sleeper shark on the west coast. These are very large, deep, cold water sharks, and they live up in the north as well. I didn't mention, but they do. Sharks that are they seem to be long-lived and slow swimming, and they exist in all around Canada as well. Some other ones, a thresher shark, fast-moving, fast-swimming oceanic shark, long tail on it. They actually use their tail to stun fish and squid before they go in and eat them. Beautiful little shark. The broad-nosed seven-gill shark is one that's found only on the west coast, but is quite common. It can be a very large shark too, with a fairly long tail, and is something that's often encountered by both fishermen and for divers out there as well. And the Shortfin Mako can be found on both coasts as well, and this is a beautiful little shark, one of my favorites, and a very fast-swimming, fish-eating shark as well. The basking shark is one of the most unusual of all the sharks that we have. This is the second largest fish in the world. It can get 8 to 12 meters in length. It's a filter feeder. It has no teeth. You can see it here with its mouth open. It opens its mouth and swims through the water column and filters particles out of the water column, and that's where it gets its energy from. Fascinating creature, definitely. Smooth hammerheads have been found here. Not very common, but they do occasionally show up in the area, as I said. We have deep water sharks. A deep water catfish is an example. There's other types called the green-eyed shark or lantern shark. There's other deep water sharks too, like Portuguese dogfish and so on. Many that we know very little about because they exist in deep parts of the ocean, but they're very beautiful. And of course, white sharks, or sometimes great white sharks, are also something that do occur in Canada. There have been relatively few observations, but we know they're out there. Nobody spends time looking for them, and the sharks are kind of difficult to find, but they certainly exist in our waters too. So what do we see sharks as? I want to just very quickly think with you about what we think sharks are and what they're all about. First of all, we see them as food. We fish them. In fact, it's the main reason there are not very many sharks out there anymore, is because we fish them. And we use them as food for us sometimes, for our animals a lot of the time. Commercial fisheries exist around the globe. Unfortunately, the problem is, as I said earlier, sharks reproduce so slowly, we can take them out of the ocean faster than they can replace themselves. And this has been very difficult for us to manage so that we can do it sustainably. And it's caused a lot of shark species to become a fraction, a minuscule percentage of what the population used to be around the world. So they're very difficult things to manage. But we see them as food, and we fish them commercially for food. We see them as pests. Often when we're fishing for other fish, like tuna and swordfish, we will catch sharks, or groundfish sometimes too, lots of things. Because we put bait in the water trying to catch one fish, sure enough a shark is going to detect that, and they often get caught. Now they don't want to catch sharks, and nowadays often they'll cut them loose and let them free. Even when we do this, sharks can sometimes retain the fishing gear in their mouths until it either rusts and falls out, and sometimes it can kill the shark, just the act of being caught and released as well. So it can cause a lot of damage to them, but they are certainly viewed as something that we don't want to have on our fisheries. Big sharks, such as basking sharks, can also blunder into fishing gear and ropes that we have in the water column and become entangled. And so sharks can be viewed as a pest for many industries that are occurring on the ocean. Sharks can be seen as sport, and sport fishermen often look to catch sharks. This is a Mako on a line here. Catching a shark on a line, I understand, is a very exciting thing. This is a Mako leaping out of the water after it's been caught on a hook. These are very fast-swimming animals, very strong, very aggressive. Once one gets a hold of a hook and doesn't want to go where you're trying to make it go, apparently they fight back quite a bit, and sportsmen and women find this quite enjoyable, so they see a lot of sport in catching sharks. Often they let them go, but not always. Often, most of the time, the shark survives if they do let them go as well. These are very tough animals too that I haven't mentioned. Finally, what do we see sharks as? We see them as monsters or evil. Many people often say, oh yeah, I like sharks, or I know about sharks. And are you scared of them? Oh yeah, I'm scared. Well, why are we scared of them? And a lot of this has to do with the fiction and attitude that we've developed in our society. It's okay to be respectful of these animals. These are large, often large fish. They are predators. They have been known to attack people, almost always by mistake. Sharks, there are no sharks out there that want to eat humans. There are easier and better things to eat out there, first of all. And second of all, they just don't want to eat humans. It's not what they're designed to eat. But we don't understand that, and we start to buy into the fiction and the stories that people tell. They are not evil, and they are not out to get us. This shark, they sort of look evil, which is part of the problem. This shark even looks like he's kind of frowning. This is another Mako. There's a beautiful shark. But he's not frowning. There is no emotion or anger to it. They eat fish, and that's what he's looking for. And we need to understand that. As I was thinking about this talk and thinking about how to present this to you, I came across an idea, and so I'm going to do a quick experiment with you guys. You can just keep track of it to yourselves here. So here's a shark. I won't even bother telling you what kind. Okay, so here's one shark on the top, and here's a second shark on the bottom. Which shark looks scarier? Which do you think looks scarier, the top shark or the bottom shark? Oh, well, for me, yeah, bottom, yes, bottom one's kind of scary. I think so as well, right? Pretty close. Okay, next test. Here's a shark on the bottom, same shark as the previous. Here's a shark on the top. Which one's scarier now? I think probably the top one, right? Interesting. All right, next test. Here's another shark, same one. Here's another shark. Which one's scarier? The bottom one's kind of skinny, but he's pretty big. I think the bottom one's a little bit scarier. If we do the test this way, here's the bottom one again, and here's the first shark. Now the top shark is scarier, I think, eh? All right, last test. Here's our shark again. I don't know if you figured out what shark this is or not. Here's the same shark. Which one's scarier? The bottom one. But it doesn't matter, they're both the same shark. I think we've just shown something. At least I showed something to myself. It's not sharks I'm scared of, it's big things I'm scared of. Sharks just happen to be big most of the time, and that's what causes a lot of our fear. Has anybody come across a moose on the road? That's scary. The moose isn't out to get me, but when you see a giant animal walking across the road, it's quite intimidating, right? The situation is the same here. These animals are not evil or malicious or out to get us. Keep in mind that there's a lot of features about them that make them intimidating, that require us to be respectful of them, but we don't need to fear them, and we don't need to eliminate them especially. Some people still think this. Okay, so what do we see sharks as? What do we see sharks are? Why do we think of them? Well, we just listed a bunch of them. We see them as food, we see them as pests, we see them as sport, and some people see them as fearful monsters. Most of these, I think, are ways we should not. They are not how we should look at sharks. And what I'd like you to take away today, if you can keep this in mind, is they are wildlife. They are animals, one of the most admirably suited animals on our planet. They've not evolved very much in 22 or 50 million years. They are designed to survive. They are designed to catch their prey and reproduce successfully, and they do that very well. They are our wildlife as well. They exist in our oceans. They deserve our respect. We don't need to be fearful of them. We can be, fearful in a respectful kind of way. We respect bears. We respect moose. I respect big cows and horses when I'm nearby them as well, because they can hurt me so easily. But we don't need to fear them. We don't need to eliminate them. They are not competitors to us or our way of life. They are something that we need to recognize as being an important part of our wildlife heritage and something that deserves respect. And finally, they are our responsibility. This is stewardship. They live in our oceans. The way we live our lives affects them. And so how we live our lives, we need to keep them in mind and be responsible for the decisions we make, the decisions we allow our elected representatives to make on our behalf, the decisions we allow in our daily lives on how they affect oceans and any marine wildlife, but certainly sharks, affects them. And we need to take responsibility for these decisions. They are our responsibility. We are stewards of a large part of the ocean on this planet, and sharks are one part of that ocean that we need to be responsible for. So, of all of these things I've talked about today, I want to end on one last note. Sharks are amazing creatures. They're so different from anything else around. They have so many amazing super features. We have many sharks that live in our oceans around us. We use them in a variety of ways, sometimes correctly and sometimes incorrectly. One thing I haven't mentioned is that they are beautiful creatures. Take a look at this. This is a juvenile Mako that was caught and it's just brought on board a boat before they put it back in the water. It's kind of small, but this is a beautiful creature. Do you think this is not beautiful? It might just be me. If you look closely, it might be hard to see on the screen. Almost every color of the rainbow is in the skin of this creature. It is so well designed. It has an immense range of behaviors. It is designed to survive. It has beautiful eyes. Its teeth are perfectly suited to what it needs to do in life. And it's just beautiful. Anyway, and this is a good enough reason for us to want to have sharks around and to manage them and be responsible for them as well. And I don't want you to forget that. Not everything needs a service or a purpose. I want sharks in my world, and I hope you guys do as well. Thank you very much for your time today. I hope I've given you some appreciation for not just appreciating what sharks are and learning to respect them, but also knowing why we should respect them and why they're important as well. And I'm sure you can learn. There are a lot of things that I didn't even touch on today. You could learn a lot more if you look into it a bit more. I really appreciate you taking the time to come and listen to me present this today. And if anybody has any questions, I'll be happy to answer them. So thanks very much. I don't know if it would be easier for us to do open the microphones or just have them on questions. There is a couple questions that I saw. Gabriola Homeschoolers from Sam asked, how thick is a shark's skin? Shark's skin is not particularly thick. Mammals can often have thicker skin. They can be very tightly attached to the muscle. It does not come away from the muscle very well, but it's not very thick. Some sharks have much more of these teeth-like projections on them than others, and some are very small. In general, I wouldn't say it's very thick. Mammals often have thicker armor, especially when you think of humans, as well as elephants or rhinoceros or anything like this. So it's not particularly thick. Second question from Sam. Could sharks detect a piece of meat under the sand and get it out? Well, getting a piece of meat under the sand, I tend to think, yeah, they would probably find it. Now, first of all, a piece of meat has no electricity going through it because it's not flexing, which is what they're capable of detecting. But sharks have this incredible sense of smell. It's the same way as if you hide treats for your dog around and your dog can find it. Sharks are tuned just like that. They're very good at finding and detecting these smells and homing in on it. So my inclination would be to say yes, very easily. They would very easily be able to smell the chemicals in the water and trace it right down to a piece of meat that you were trying to hide in the sand. And another question I have, what do you mean by managing sharks? I hate when I use terms that are vague like that. Manage, how do I manage sharks, right? We don't manage sharks. We can't manage animals at all. We manage the way we use them. We manage the way that we fish them. And this is what I mean, this is what I meant, and this is what I should have said when I said manage sharks. We fish them and treat them differently. We have commercial fisheries that must follow specific rules about where to fish and when and how to fish, which fish to keep and how much to keep. And these are important rules that we make for making sure we can take sharks out of the ocean, but making sure there are always sharks in the ocean. Those are the rules we need to be careful of. We also have rules that say how much pollution we're allowed to put out from our cities, if people are doing recreational fishing, how they handle sharks, how they should handle sharks, how they return them to the ocean. These are the rules for how we use sharks, is what I mean by managing them. And these are the things that we need to be attentive to. 5 questions. How many babies do they have? That's a good question. It's a bit complicated because different sharks will have different numbers of babies. Some sharks will have only 1 baby, but it'll be very healthy and it'll be very big. Other sharks are able to, for example, lay multiple egg cases in a given season. One thing I didn't mention is how old sharks get. We're not totally sure for some of them. There are some sharks we're unsure of, but they tend to be long-lived animals. This means over a lifetime, they can actually have quite a few babies, even though it takes a long time for them to get to the stage where they actually can have a baby. So the answer is they usually have few babies at any one given time, but over the course of their lifetime, they can have many babies. Do they make a noise? That's a good question. I don't think so, but perhaps they do. Many fish do grunt and make noises. Usually they use their air bladder to do it, and these guys often don't have air bladders. I don't know if they make noises, but they do have very complex behaviors, and so that's a good question. Someone will need to work on it. How fast can they swim? Some of them are very slow swimmers. They can almost always burst very quickly over very short distances because they're designed to grab things quickly. The fastest swimming fish in the ocean is sometimes debated to be a shark. Sailfish and swordfish are often considered fast swimmers as well. But the Shortfin Mako, this little beautiful fish that I showed you on the previous slide, I'm going to show you again because it's just so beautiful, is considered the fastest shark. They are not sure how fast it goes. There have been records up to 30 kilometers an hour. Some say 50 kilometers an hour, and others say that the biochemistry of these animals means that they could go even faster than 50 kilometers an hour. Can you imagine a shark swimming through the water as fast as a car driving along the road in front of your house or your school? It's amazing to think that they could go that fast. Are they dangerous when we get close to them? Not usually. Most sharks don't want to be near people. We cause a lot more damage to sharks than sharks ever do to us, which is part of the reason why we need to be so responsible. Sharks usually will know you are a person, and they are not interested in interacting or dealing with people. Sharks can hurt people by mistake. Does anybody have a pet cat? I often think of cats. You know, if somebody has a cat and you're patting your cat and it doesn't want to be patted anymore, usually you know that, right? People who don't know anything about cats will keep patting the cat until it hisses out. Not going to know. How they're going to react and behave. So, for the most part, are they dangerous when we get close? Any wildlife you're close to is dangerous. You don't want to be near wildlife in any sort of situation like that. You should be respecting them and giving them lots of distance. But it's not something you should be fearful of. It's something you should be respectful.